Okay, guys and gal, this is the information that you're going to need for lab objective number 13, which is the air disc brake. Okay, so the first thing we're going to do is we're going to do a couple of measurements. Jason, our videographer, is going to get some nice tight shots of the micrometer, or the dial indicator, excuse me. The first movement we're going to do is one of your inspections that you'll do on any brake job is basically the back and forward of this caliper. All right, this is a sliding caliper. It is not fixed, it is sliding, and I know that for two different reasons. I have two pistons on the inboard side. I have no pistons on the outside. So that means that this is going to slide back and forth. You will have to look up the industry specifications of what this should be. But I'm going to have Jason zoom in. I've got the dial indicator set up on the back end of the caliper. I'm going to get it to 0, and I'm going to push it all the way one way, and then you guys can see what that movement is. So when I push it all the way one way, I can see I've probably got some excess movement there. All right? Pull it back, and it goes back to 0. Push it back. Then we've got about whatever that is. You guys can figure that one out. Okay? So this is one of the areas that you'll need to put in your service report and also on your lab objective sheet. Okay, so the next one we're going to do is called lateral runout. And the way I'm going to do that is I'm going to set my dial indicator. Actually, it could be off of here. It's going to be easier if I set my dial indicator right on the edge up the top. So I'm looking at how much out of round we are here. All right, so we'll set up our dial indicator. And again, I'll have Jason, our videographer, will get a nice tight shot of our micrometer, or a dial indicator, excuse me. So what I want to do is make one full revolution. So I'm going to take a Sharpie, and I'm going to make a mark right on the top. So I know when I have my full revolution. All right, so we're sitting right here, and I'm going to 0 a dial indicator. And I'm just going to roll it around really slowly. So you want to watch if the dial indicator is going to move either plus or minus either side of the 0. And we're going to add those two numbers together. So if I was to, this needle's to come up to 2 thousandths this side, then go to 2 thousandths that side, that means my travel is 4 thousandths of an inch. Okay? So let's go ahead and roll it around, see what we got. So nice and slowly. Okay, see I'm moving positive. And there's one full revolution. Okay? The next measurement we're going to take is a lateral runout. That is where I'm going to have our dial indicator on the back side. So what I'm looking for here is basically wobble back and forward. Now keep in mind that wobble back and forward, that could be that the rotor is out of round. It could also be that our wheel bearings are going bad. All right? So you'd have to determine from that. I mean, if you think your wheel bearings are bad, you would actually have to take your hub off and measure and play your wheel bearings, all right? So we're going to go ahead. I'm just going to have Jason pause right now. All right, so we're back. So we're going to do a measurement of our lateral runout. So again, I need to make one full rotation of the disc brake. So I'm going to take my trusty little Sharpie. We'll make a nice mark here. So that's our starting point right there. And we will 0 the dial indicator right to there. All right, so again, same thing as before. You're going to be looking at the needle if it either goes negative or positive off of 0. So if it goes to 2 and then comes back this side to 3, the total runout, the TIR, total indicated runout, will be 5 thousandths. All right? So you'll have to check your specifications and see if we're in or out of spec. All right, so let's do one full rotation, starting with this mark right here. So again, nice and slow. And there's one full rotation. Okay? So that's our three of our measurements with our dial indicator. The last measurement that we would take will be with a micrometer. All right, this is a 1 to 2 inch mic. And we are going to be measuring, and I'm just going to use this first one as a reference point right here. I need to measure 3 different spots. I need to measure, I'll get my Sharpie, we can kind of see where we're going to measure. I need to measure one spot out here, one spot towards the middle, and then one spot towards the inside. So this will be our outer rotor measurement, inner rotor, and middle rotor, and our inner rotor. You will note, however, that this micrometer is not going to fit all the way in. It's going to go in that far, all right? The other thing that we need to do is I need to make these 3 measurements at least 3 different places, okay? So I'm going to do one here. I'd rotate over, third of a turn, rotate over, do another third, all right? So this is what we're going to do, guys. It's pretty straightforward how we're going to do the measurement. I'm just going to come in here and we'll do our measurement, take this off. So what I'm going to do is I will take pictures as I've done in other labs. I will show you the measurements. You can determine what the measurements are. So I will post that online for you because obviously I've got to get a deeper micrometer. All right? So that'll be our 4 different measurements that we'll be taking. 3 with the dial indicator, then 1 with our micrometer, 1 to 2 inch. Please remember when you look at the measurements, you're starting off with 1 inch. All right? So if you have a .987, that's incorrect. It would be 1.987, all right, because this is a 1 to 2 inch micrometer. Okay, we're going to pause and we're going to go to the other side and we're going to take the other side apart. Okay, we're back. You can see we've moved to the other side of the truck. So what we're going to do is we're going to take out these 2 disc pads right here. This is a whole lot easier than taking apart a drum brake. I can see that I have 2 disc pads, one on either side. Here's my caliper, here's my air actuator right here. I have a hold down clamp, I have a pin, and I have a lock. So if I take my trusty vice grips, and yes, this is one time you can use your vice grips, and we're gonna pop out the keeper. Guys, these parts are pretty small, so let's make sure we don't lose them. So we'll just set them on the springs, set that beside. I just push down on this because I have 2, kind of like a Bellevue washer. So these clips right here, they're spring loaded. I push down, pop my pin out, and then this comes right out. Okay, really, really easy. Next thing I'll do is I can grab 1 pad and I can grab 2 pads. All right, so here's my disc pads. Obviously these are a little bit rusty. This truck hasn't been on a highway for quite some time. You typically won't find a whole lot of rust on these things. So let's just sit them down. So here I can do some inspections. Well, number one, I'm going to inspect my pads. If there's any cracks, if there's any chips, if there's abnormal wear, we've got one side wearing more than the other, etc. This is a sliding caliper, so both sides should be wearing evenly. I can check my boots on the inside, my seals. Okay. Part of my inspection also would be my hose for my air. Make sure there's no leaks. You'll note the wire. This wire would indicate that this is an ABS system, so anti-lock braking. This wire is a pigtail for my wheel speed sensor. All right, so we're going to take the caliper off. So the caliper itself is held on each side by 3 bolts. And this happens to be a 14 millimeter half-inch drive Allen head. All right, so I've already loosened these up and taken these off. They are torqued down, and I can't remember what the torque is, but it's pretty substantial. All right, so now all I have to do is I'm just going to lift off the caliper. And here I can see, probably from here I could do, if I was to do my measurements with my micrometer and my dial indicator, it'd be a lot easier with the caliper off, but you do not have to take the caliper off to get those measurements. You can also see on this side down here that I do have a locating dowel. So this one sits in this hole, so this just helps me locate things when I go back together, okay? I can inspect my rotor. One of the uploads I put in Brightspace for you guys was from Goonite, and it shows you some pictures of what you do not want to see on a rotor. So heat checks, heat cracking, chips, gouges, whatever. Any chips or gouges, this rotor is going to be taken out of service. The measurements that you take, if you're outside of your industry specifications, this rotor would be out of service, okay? So this rotor is part of the hub. So this is an assembly. Before you start tearing this thing apart and telling your customers you're going to replace it, make gosh darn sure that you've double-checked all of your measurements to justify that you are going to replace that component for your customer. Okay, so going back together is just as easy as coming apart. So we're going to lift this puppy carefully on, find our locating dowels, it sits down nicely. Then I would just take my 3 bolts, 3 of them go in here, 3 on the back side. I would use get my torque, I'd use my torque specs, would spec it down. Then we'll put in our pads, inboard pad, outboard pad, put in my hold down clamp, put in my retaining pin, put on my washer, and my clip. And just like that. So after I put my bolts in, I put my bolts in before I just reassembled. Now we're set in place. All right, so now what I would do, we're going to take a pause and we're going to go back to the other side and I'll show you how we actually adjust our brakes. All right, we are back to the other side of the truck again, our first side. So now I'm going to show you how to adjust the brakes. First of all, we are going to pop off our boot over our adjuster, which is this one right here. Flat blade screwdriver, tweak it, and it will eventually pop off right there. We'll set him aside. Then I'm going to use this special tool. If Jason, if you can zoom in on here, this is our adjuster right here, okay? This is the special tool that we're going to use. This, guys, is kind of spendy. I'm actually going to get a couple more for our lab. On Amazon, $15 to $20 for one of these, all right? So this is a 10 millimeter socket, fits inside, then this mates up to here. And if I go clockwise, I'm going to tighten up the air gap between the rotor and the pads. So right now, I cannot move that. If I go counterclockwise, you can hear it clicking over itself. So 2 clicks is about a quarter of a turn. So I want to take this back about a half of a turn. So that was 2 clicks. I'll do 1, 2 more. I'm going to take this off, try not to lose it. Now I can see that I have some free play. I'm guessing that's probably too much. So What we'd have to do is we would set up our dial indicator, the same as our very first measurement. It will be off the back side, mounted onto our axle, and we would actually move this back and forward, and we could figure out if we're in spec or out of spec. I'm guessing that we're out of spec, so all I would do is I would just take this up, I would put this adjuster on here again, and I would adjust this so this air gap right here closes up. All right, so we do want to be within our industry specification. And that is something that you can get from the literature that I'll be posting online. Okay? So with that, you should have all the information that you need for objective number 13, which is your air disc brake. In my mind, these are way easier to work with, especially taking measurements, etc., than your drum brakes. They also are a lot more efficient, as you'll see in the lecture that I'll be putting up online on Wednesday. Okay. As I said, I will be posting the measurements of the micrometer, of the thickness of our rotor, so I'll put those up online for you. All right, thank you and good luck.